Hello, welcome back. Today we're going to solve the top three um, algebra coin problems. So we already discussed about the number, measurement, set theory, and also the mixture problems. And then for the fifth part, we're going to solve coin problems. Alright, so the first problem. So a coin collector had a collection of silver coins worth $205. Okay, if you continue, there were 5 times as many quarters as half dollars and 200 fewer dimes than quarters. How many of each kind of coin did the collector have? Now, for specific to coin problems, we need to define first the so-called the coins, no? So in a $1 coin, okay, this is important to so in a $1 coin, so we know that there are what you call this 0.5 dollar half. This is half dollar. Okay, so there are, okay, sorry, I should 2 times 0.5. okay, so there are 2.5 we call this one half dollar, okay, HT. And then there are 4 quarter, so quarter is 0.25 US dollar or dollar, and this is quarter, okay. We call this one the quarter, or maybe we erase this one first, okay. And then for the dimes, we have 10 times times 0.10 dollar. So this is what we call this one. We call this one dime or dimes, and this one we call this quarter. So I designate dime with D, Q for quarter, and then half dollar as H. Actually, there's it's not stated in the problem, but you can use the 100 times 1 cent. Okay, some problem uses the cents. Okay, so now so in this problem, the total number of half dollar, we designate this one as H. The total number of quarters is Q, and the total number of dimes is D. Okay, so we only in this problem we only focus on the H, Q, and D variables. So what are the how many half dollars, how many quarters, how many dimes. So these are what is asked in the problem. Okay, so how many of each kind of coin. So these are the kinds of coin. Okay, so let's go back to the problem. So the problem is saying that there are 205 US dollar there are a number of silver coins worth $205. Okay, now this is composed of 0.5. okay, we still follow the unit consistency. Okay, we need to be unit consistent. Okay, so that's why I'm writing to you the unit to be consistent, to be aware of the unit. If you're an expert already, you don't need to you're confident, you don't need to write the symbol or the currency. So $0.5, so there are the number of coins for the dollar, sorry, half dollar. So this should be H plus 0.25 quarters, so Q number of quarters, plus you have call it 0.10 D for the D number of dimes. Okay, so you see the pattern is that actually this one is dollar, and then this one is per coin, diba? Per coin, and then the unit of this one is H coin, how you call this, H number of coins. Okay, so therefore cancel the coins and then cancel the coins. So this is to observe the unit consistency, so that the resulting value here is 205. So I mean the unit is dollar. Okay, we're dealing with dollar, so all of them should be in dollar. Okay, so 0.25 coin per per coin, not per coins, per coin. And then Q, number of quarters are coin, so cancel the unit coin, and then the other one is coin, so you also cancel the coin. Okay, so very simple. So we can express this one into 205 equals 0.5 H plus 0.25 Q plus 0.10 T. Okay, so now there are three variables in the equation, so we need two more equations to solve this, to solve each of the variable H, Q, and D. Okay, now we in the problem there it is stated that there were 5 times as many quarters as half dollar. Now you might be tempted to write as 5Q equals to H. Okay, but this is incorrect. Okay, so this is incorrect. So the phrase said that the quarters are 5 times more than 5 times as many as half dollar. Okay, so be careful with that. Okay, so the way they state the given, so we need to be careful. Okay, and then the other one is, and 200 fewer dimes than quarters. Okay, so it means the dime is equal to quarter fewer than 200, or less than is less than less 200. Okay, so this is how we express. Now so where you can solve, so we have, this is our second equation, and then this is our third equation. So we have the first equation here. Okay, then we can do the basic. No, we substitution method. Okay, and or whatever. So in this case, the simplest one is to find first one variable. In this case, it's easier to solve for H. Okay, by substitution method. So I substitute Q here with a Q of number 2, so this becomes D is equal to 5H minus 200. Okay, and then this one I call it 3 prime. Okay, so I will substitute this number 2 and number 3 to equation number 1. Okay, so that what remains is the variable H. We have 0.5H plus 0.25 times 5H plus 0.10 times 5H minus 200. Then you can find the value of your H. Okay, so these are the number of half dollar coins. Then after you find the number of half dollar coins, then you can get the quarters or the dimes. Okay, using the formula of this one from number 2, and then also number 5. Okay, and solve for the number. Okay, so I leave that to you to solve this problem. I know you can solve this on your own. You may use your calculator to be more effective. You can check out the video on how to use your calculator faster. you can solve this problem faster, especially if you have 3 equations, 3 unknowns. Okay, so the second problem. Mr. Denkel's file bought a $32.56 dollars worth of stamps. Okay, so seems similar with the previous one. Okay, so you have yes, $32.56 dollar worth of stamps. He bought 20 more 19-cent stamps, okay, than 50-cent stamps. Okay, $32.56 equal to, so you have 19-cent stamp, 0.19 cents. Okay, and this cent is composed of 20 more stamps than the 50-cent stamps. So let's say you have 20 more than the X. So we assign X as the number of 50-cent stamps. So we have here 50 cents stamps. Okay, so you notice this one is the stamp, this one is the per stamp. Okay, so to follow the unit consistent, and then this one is stamp, the number of stamps. Okay, so you cancel it out. Okay, so that the unit is dollar. Okay, so these are the multiple of, or how many, this one is how many 0.19 cents, okay, or 0.19 dollars. Okay, so that to sum up we have 32.56, and then this is also the same, stamps, and then per stamp. Okay, so these are the units, so we cancel this one. Okay, and then another there's still in addition, he bought twice as many 32 stamps. So there's a 32 stamp he bought with a total amount, so this 0.32, okay, as so twice as many as 19-cent stamp. So the 19-cent stamps, the total number is 20 twice. So he said twice as many as 20 plus X. Okay, in the previous video, so I show you that you can actually represent this one as X, and then this one is Y, then this one is Z, or you assign 3 variables. But in this case, it's I don't know, but it's quite exciting, or it's quite how you call this, it's easier to do this. Okay, I mean, it's more challenging, and it's more how you call this, actually, if you know this technique already, then it's probably you need some practice, and then you can perfect this, no? So this is the same, this is stamps, the number of stamps, and then this one is per stamp. Then you can cancel this one also. Okay, so you see, this is a mathematical expression, then we convert this one into mathematical equation. So $32.56 equal to 0.19 times 20 plus X plus 0.5 X plus 0.32 times 40, 2 times 20, then plus X, 2X. Okay, then you have one equation and one unknown. You can solve for the number of X. Okay, the number of X, so actually the X here is the number of 50-cent stamps. Okay, so this is for the 50 stamp, 50-cent stamp, and then for the 19-cent stamp, so you have 20 plus X is equal to you have 0.19 stamp. And then for the 32 cent, so you have 40 plus 2x, or 2 times the 19 cents now. Okay, so you have this one, and then 0.32 cents now. Okay, I hope you learn how to. The most important thing here is how to do this part. Okay, so this mathematical expression. Don't worry if you have a lot of erasures. That only shows that you really focus, no, on the problem. No? Most of the good or best students, they even have very you call this very dirty equations, or there are many erasures. But don't worry, as long as you follow the rule that is to be unit consistent. Okay, so you leave the solution or the way to solve this on your own. Okay, so let's proceed to the third algebra problem. Okay, welcome back. So you have 64 cents. So you have a collection of coins at 64 cents. Okay, now this one is not anymore dollars, but in terms of cents. There are 2 more nickels. Now there's an additional nickels. They're in $1. So you have 20 nickels, or 20 times 0.05, okay, or 5 cents. Okay, and then there's another term here we call penny. So you have in $1, so you have 100. So actually this is 1 cent. Okay, 0.01. So this is 1 cent. Okay, so there are 100 cents in $1 coin, or in $1. Okay, so 24 cents. There are 2 more nickel, okay, than dimes, and 3 times as many pennies as dimes. How many of each kind of coin are there? Okay, so we can write there are 2 more nickels than dimes. So we can write the nickels, the dimes, then pennies. So nickels, I can write nickels. So nickels, and then the number of nickels times its value, which is now you don't use 0.05 because it's not consistent with the cents. So what we can use here is only 5. Okay, 5 times the number of nickels. Okay, plus dimes. Dimes is how many dimes in $1? So we have 10 dimes. Okay, 10 times the number of dimes, and then plus 100 10 cents. Actually this is 5 cents, the value of 1 nickel. Okay, this one is per nickel. Okay, per nickel. Okay, so that you can cancel the nickels. Okay, so the remaining value is a scalar value of the number. So this one is 10 cents. Actually this is cents. Okay, per dime. Okay, I forgot to write this actually to 5 cents per nickel, and then this is 10 cents per dime. Okay, so you can cancel dimes. Then also the 100 it's only 1 cent per penny. Then this is times the number of pennies. Okay, so yeah, so this is the mathematical expression, and but we need to write the number of nickels. So this is there are 2 more nickels than dimes. So it means actually we can make a graph here. So the nickel is 2 more than the dimes. Okay, and then 3 times as many pennies, so we have pennies is equal to 3 times the dimes. Okay, so we can actually represent everything, the nickel, the number of nickels, and the number of pennies into dimes. Okay, so therefore you have so the n here can change with the 2d, so 5 times 2d plus 10 times d, so the d is the number of dimes, and then plus 1 times p, sorry, I forgot, 3 times dimes, so you have 1 times the p is equal to 3d. Okay, then this is equal to 64. Okay, very simple, you just add all of them, so we have 10 plus 10, 20, 23, so 23d is equal to 64. Okay, so so dimes is equal to 64 over 23. Sorry, I think we made a mistake here. The nickel is 2 more, so therefore this should be d plus 2. Okay, so we made a mistake here. You can just simply write 2 plus d. Okay, 2 more, and then the other one is 3d. Okay, so we made some mistake. So if you notice, if we divide this one, it's not a whole number. Okay, or in an integer or whole number, so it's not a whole number, so therefore there must be some problem with our equation. That's why, so this is incorrect. Okay, so it's good to make some mistake, so we can be probably the mistake is common, and we can overcome that. So we have 10 plus 5d plus 10d plus 3d should be equal to 64. Okay, so d is in 18d is equal to 64 minus 10, transpose 10 to the other side, so we have 54. So the total number of dimes should be equal to 3. Okay, so 3 times 18 is 54. Okay, and then it's easier now to find the number of nickels, number of n, or n is equal to 5, and then pennies is equal to 3 times 3 is equal to 9. Okay, you can actually verify whether they are 64. 3 times 10, okay, 3 times 10 equal to 30. Okay, nickel is 5 times 5, so there are 5 nickels, so this is 25, and then pennies is 9, so 1 times 9, so this should be equal to 64. So if you add all of them, so you have 4 carry 1, so you have 64. Okay, so fantastic. So we have 64 cents. This is cents. Okay, so that's it. So that's the end of our how you call this, the coin problems, top 3 coin problems in algebra. Okay, so in summary, we have solved 5 problems, top 5. We have solved top 5 of measurement problems. We have solved top 3 of the set theory, also top 3 of the mixture problems, top 3 coin problems. These are to demonstrate to you the common, the most basic problems of algebra. And then actually there are many more problems for algebra, and this is actually in a linear systems. So we have age problems. An age problem can be a number problem. Okay, the only difference is that for example, because the time changes, or the number of years, something like that. So soon we will post some age problems, especially those are basic for the age problem, but it is quite related to the number problems. And then other challenging problems, for now, we will soon create a video for this, for some challenging problems that is also common, no, for difficult type exams or tests, no. So we will post it in this channel. Okay, so in the next set of videos, okay, so we will do some research and conduct the top trigonometry problems. Okay, so in order to do that, so don't forget to subscribe in this channel, and then so you will be updated with the latest and I call this well-researched problems in algebra and other mathematics. Maybe soon we will have other engineering problems in electrical, mechanical, or even artificial intelligence. Okay, so thank you so much for listening, and I hope you get some understanding and skills in solving algebra. If you have some comments, suggestions, please comment in the comment below. Okay, so thank you so much.